Hi, welcome to my channel pibyme Maths. This is by WST01. Here we are solving May-June 2020 Statistics 1 paper. You need to remember this is the same paper used for October-November also during the COVID time. So let's look at question number 1. The discrete random variable x takes these values. Given that the probability function is given, find E of x. So the formula for E of x is sigma x times P of x. So when you sub in x is minus 1 here, you're going to get 8 over, okay, that's a 5-mark question. You know why it's a 5-mark question? Because there's a k here. We need to find the k first. So before finding E of x, I'm going to find k first. We know sigma P of x is equal to 1. So sum of all the probability will be equal to 1. So sub in the values of x 1 by 1. When you sub in minus 1, it's going to be 9 over k. Sub in 2, x minus 2, 6 over k. 3 is 8 minus 3, 5 over k. 4 is 8 minus 4 over k. 8 minus 7 over k is 1. So add them, you'll get 15, 10, 20, 25 over k is 1. That means k is 25. Now we can find E of x. The formula to find E of x is sigma x times P of x. So in every probability you will have 1 over k, which is 1 over 25. I'm going to take it as common factor. Now x times this. So minus 1 times 9 plus 2 times 6 plus 3 times 5 plus 4 times 4 plus 7 times 1. Let's calculate this now. So minus 9 plus 12 plus 15 plus 16 plus 7. So 41 over 25 is the final answer, E of x. Let's look at question number 2. In a school canteen, students can choose from a main course of meat, fish or vegetarian. They can then choose a drink of either water or juice. The letters are given here for meat it's M, fish F, vegetarian V, water W, juice J. The partially completed tree diagram where P and Q are probabilities shows the probabilities of these choices for a randomly selected student. The tree diagram, I put the tree diagram here. Complete the tree diagram, give an answer in terms of P and Q. Okay, now you should know always this probability should be, sum of this probability should be equal to 1. So if these two are 0.75, apparently this is 0.25. So if this is P, this will be 1 minus P. If this is Q, this will be 1 minus Q. Because the total probability should be 1. This is 0.4, this will be 0.6. That's all. Part B. Find an expression in terms of P and Q for the probability that a randomly selected student chooses water to drink. They want us to find P of W. So look at this one. It can be meat W or fish W, water, or vegetarian and W. So you multiply these probabilities and sum up. You can write it as P of meat W plus fish W plus vegetarian W. So that's going to be 0.40p, 0.4p plus 0.35q, 0.35q plus 0.25 times 0.4, which is going to be 100, so 0.1. So the answer is 0.4p plus 0.35q plus 0.1. That's just a 1-mark question. Part C now. The events choosing a vegetarian main course and choosing water to drink are independent. So they are saying P of V and P of W are independent. So we know the formula for independent events. P of V intersection W should be equal to P of V times P of W, right? So what's V intersection W from the tree diagram? This is V intersection W, the multiplication of these two. So just put it here. 0.25 times 0.4 is equal to P of V. This is P of V, the highlighted one, 0.25 We have calculated P of W in the previous part actually. This is P of W. 0.4P plus 0.35Q plus 0.1. They want us to frame a linear equation in terms of P and Q. We can cancel these two. So we will get 0.4P plus 0.35Q plus 0.1 is 0.4. So you can just push this number also this side. So the answer is going to be 0.4P plus 0.35Q is equal to 0.3. That's all. Let's look at part D now. A student who has chosen juice to drink is selected at random. That's a condition. Find the probability that, now the probability they choose fish as a main course. The probability is given already. The conditional probability is 7/30. The formula for conditional probability P of A intersection B over P of B, which is given as 7/30. Okay, in the Venn diagram we are going to find F intersection J. This is F intersection J is 0.35 times 1 minus Q. 0.35 times 1 minus Q divided by P of J is 7/30. Now listen to me carefully. If you look at the second category, there are only two, water and juice. So the complement of water, W complement, is juice, right? We know from the previous part, V and W are independent of each other. So this is the result you should remember. It might be useful in some other question also. If A and B are independent, definitely A complement and B also independent. A and B complement is also independent. You need to remember that, okay? So here, since V and W are independent, V and W complement, which is basically J, are also independent, right? Now I'm gonna use the formula for independent events now. So this will be the easiest way to calculate it. So you can write P of V intersection W complement is equal to P of V times P of J. From the tree diagram, V intersection J is this. V intersection J is multiplication of these two. 0.25, 0.60. 0.25 times 0.60 is equal to P of V is just this, right? 0.25. 0.25 times P of J. So make P of J as a subject. Cancel this 0.25. So I will get 0.6. Sub in here. Therefore, 0.35 times 1 minus Q divided by 0.6 is 7/30. And then make Q as a subject. Therefore, Q is equal to 7/30 times 1 minus Q is equal to times 0.6, everything divided by 0.35. So you can find Q. So 7/30 times 0.6 divided by 0.35, 2/5. So 1 minus 2/5 is going to be the value of Q. That's the easiest way to find Q. Now we have an equation here in the previous part. Sub in the value of Q here, you can get. So 0.4P plus 0.35Q plus, is equal to 0.3. Correct? That's the equation, yes. So make P as a subject. You're gonna get 0.3 minus 0.35 times 0.6 divided by 0.4. 0.225 is the value of P. Part E now. The canteen manager claims that the student who choose water to drink are most likely to choose fish as main course. That means water to drink, choose fish as main course. This probability should be higher compared to meat water, compared to vegetarian water. This should be larger than these two. That's what they are saying actually. Okay, let's find P of W, F given W. P of F intersection W over P of W. We know the value of P of W, which is 0.4. because P of J is 0.6 in the previous part. Therefore, P of W is 1 minus 0.6, right? F intersection W. From the tree diagram, F intersection W. 0.35 times Q. 0.35 times Q. 0.35 times 0.6 divided by 0.4. Okay, let's calculate this now. 0.35 times 0.6 divided by 0.4. I get 0.525. Okay, there are three properties: F and water, meat and water, vegetarian and water. The total of all the properties should be equal to 1, right? But this property is already 0.525, so sum of these two will be 0.475, right? So anyway, this has the highest probability, correct? So therefore, the manager's claim is correct. So you need to write P of F given W is equal to 0.525 is larger than P of M given W and P of V given W. Therefore, the manager's claim is correct. Question number 3 now. The distance achieved in a long jump competition by students at a school is normally distributed with mean 3.8 and standard deviation 0.9. Student who achieve a distance greater than 4.3 meters receive a medal. Okay, if you draw a bell curve, the mean is 3.8. So if anyone jumps 4.3 or more than 4.3, the people in this category, they are the one who receive a medal. Find the proportion of students who receive medal. We need to find this area actually, the proportion of this area. So they are talking about long jump, the distance. So I'm going to use D follows normal distribution of mu comma sigma square. Part A, we know P of D is greater than 4.3. We need to find this property. Standardize it. Z greater than 4.3 minus 3.8 over 0.9. So let's calculate this. 4.3 minus 3.8 divided by 0.9, 0.55. So P of Z is greater than 0.56. So the area on the right hand side of 0.56 is same as 1 minus P of Z is less than 0.56. So take the table value, subtract from 1. For 0.56, the table value is 7123. So 1 minus 0.7123, you will get 0.2877. That's all. Or you can round it to 3 significant figure. The school wishes to give a certificate of achievement or medal to the 80% of the students who achieve a distance of at least D meter. So if anyone jumps D meter or more than D meter, 80% of them, right, will receive a certificate. The school wishes to give a certificate of achievement or a medal of 80% of the students. So I'm going to draw a bell curve where the mean is 3.8. So if anyone achieve a distance of at least D meter or more than D meter, 80% of him. So we are going to take 80% of the students. So let's say D is here. How do I know D is here? Because they say 80% of the students who jump D are more than D. So this is, we know the area below the curve is 1. This is 50%. And then in order to be this to be 80, we need to have D here, right? So this will be, this whole thing is 80%, correct? So this will be 20%. So you can write, we need to find the value of D. We can write P of D is less than small d is 20%. Standardize it. D minus 3.8 over 0.9 is 0.20. right? So if we take a similar value here, the area on the right hand side will also be 20. So you can write z is greater than, change it to positive, 3.8 minus d over 0.9 is also 20. This is greater than, it's a positive number, it's a neat value, 0.20. So we can use a smaller table. So look at the smaller table for 0.2, then the value is 8416. So 3.8 minus d over 0.9 is 0.8416. Make d as a subject. 0.8416 times 0.9 minus 3.8. 3.042, 3.0425, etc. Round it to 3 significant figure, 3.04. That's the value of D. Of those who receive medals, okay, to receive medal, you should jump more than 4.3, right? So of those who receive medals, those who jump more than 4.3 meter, the 1/3 who jump the furthest will receive gold medal. Okay, you see here, we have a bell curve, 3.8 here, and then 4.3 here, let's say. All these people in this category are going to receive the medal. But those who jump 1/3 of those who jump furthest will receive gold medal. So let's say this is 1/3 of him who jump furthest. This part, only this part. We don't know this value. I'm going to take it as A. So those who jump more than A will receive gold medal. So D is greater than A. This is a conditional probability. But this will be 1/3. It says, okay. Find the shortest distance G meters. Okay, we don't take it as A, we take it as G. That must be achieved to receive a gold medal. The shortest distance is G, right? Apply the conditional probability. It should be more than 4.3 and more than G. So it should be, the intersection is more than G, divided by P of D is greater than 4.3 is 1/3. We know the probability of this already, right? We have calculated it here, which is 0.2877. So bring the 2877 this side. P of D is greater than G is 0.2877/3. Standardize it. Z greater than G minus 3.8 over 0.9 is 0.2877/3. 0.0959, right? So it's a positive number, Z is greater than. So area on the right hand side of positive number is this. So area on the left hand side of the positive number will be 1 minus of this value. So 0.9041. Therefore, G minus 3.8 divided by 0.9 is, use the table value. Look for 9041 or the closest value. 9041, we have 9049 here. 1.31, I'm going to use 1.31. Okay, that's the closest value, right? Because 1.3 is 9032. This is 9 units away. This is just 8 units away. So 1.31 times 0.9 plus 3.8, get 4. G is equal to 4.979. Therefore G is, round it to 3 significant figure, 98 is the answer. That's all. Okay, the last part. A journalist from the local newspaper interviews a randomly selected group of 3 medal winners. Find the exact probability there is at least one gold medal winner in the group. At least one is basically X is greater than or equal to 1. It can be 1 or 2 or 3. When you rewrite it, it's 1 minus p of x is less than 1 or x is 0. Okay, the gold medal winner, if you look at the previous part, 1/3 is a gold medal winner. So the probability of success here is 1/3. Probability of failure is 1 minus p, that's 2/3. So when they say x is 0, 1 minus x is 0 means all three are not gold medal winners. Actually, this is binomial distribution. Actually, usually they will ask a binomial distribution question. The formula is this: NCX p power x q power n minus x. So NC0 p power 0 q power n minus 0. You will learn this binomial distribution in detail in statistics 2 actually, but in statistics 1 this is the only type of question they ask with, mostly with normal distribution. So it's basically 1 minus 2/3 power 3. That's 1 minus 2 cube over 3 cube. 19/27 is the answer.